So, you've probably heard the term superbug or antibiotic resistance thrown around a fair bit recently. And what this relates to is a bacterial infection that isn't able to be effectively treated using one or more antibiotics. And this is scary stuff, really. What we're talking about here is the antibiotics that we've relied on so heavily being rendered completely useless. And where would we be with our antibiotics? Well, this would set our medical system back to the early 1900s, where even a simple cut on your knee could result in a golden staph infection that would claim your life. And perhaps the scariest thing of all is that at the current rate, this is something that we will see during our lifetime. So what do? Well, we need to come up with an entirely new generation of antibiotics, ones that the bacteria aren't as able to develop resistance to. And this is where I think Mother Nature might have provided us with a possible solution. You see, animals and plants under certain circumstances are actually able to make their own antibiotics, and these are what we call host defense peptides. They're called that because they defend their host against invading bacteria. And you see, bacteria have been exposed to these peptides for millions of years and don't really show significant signs of resistance yet. So, how do these peptides work? Well, it has a lot to do with their structure, which is a little bit like this branch here. You see, peptides have a long backbone with pendant groups that come off at regular intervals. And you see, some of these pendant groups are really good at recognising and binding to bacterial membranes, while others are able to actually insert into that membrane, bursting it and killing the cell. So you see, for the bacteria to develop resistance to the peptide, they would have to change their entire membrane structure, something that's almost impossible for them to do. So, we have these peptides that work really great against bacteria. Why aren't we using them? And you see, the big problem with peptides is that our body's able to break them down really easily. That would mean that the peptides couldn't exist in our body for long enough to have their desired effect. So this is where our work comes in. What we want to do is to take those essential characteristics from those peptides and actually mimic them using polymers. You see, polymers, being synthetic, aren't as readily broken down by the body, and they're fairly cheap to produce. And in fact, they can have very similar structures to the peptides, with a long backbone with repeating pendants at regular intervals. And in fact, our polymers are so good at mimicking those peptides that they too are able to kill a broad range of bacteria, even some that are currently resistant to conventional antibiotics. And even more excitingly, when bacteria are exposed to our polymers for extended periods of time, they don't really show any signs of resistance. So, our polymers, perhaps the next generation of antibiotics, and the answer in the fight against superbugs.